All right, so good day, class. And before we formally start our discussion, let us take a moment to pause and seek guidance for today's session. Let us pray. Dear Lord, we thank you for gathering us today in this virtual classroom. Bless us with wisdom, focus, and patience as we learn together. Guide us to use this time meaningfully and help us grow in knowledge and understanding. Amen. So once again, good morning, class. I hope everyone is feeling well and ready to dive into today's lesson. Actually, I am happy to see you all of you here, even virtually. Okay, just remember that your active participation is key to making this session productive and fun. Since this is a recorded session, here are a few reminders. Please everyone take notes and pause the video if needed. And then answer the questions I will ask during the lesson in your notes. And then review the additional materials provided, okay? And you have to try to seek a place which you prefer to or away from any noise because I want you to set a comfortable pace for yourself. All right? So just be ready. Now, before we move on today's topic, let's take a moment to recap what we discussed last time. You may pause the video and then remember those topics. All right. So in our previous session, we covered about the topic improving a classroom-based test. So now, before we dive into our main topic, I have prepared an activity. Okay, so before we dive into our lesson, let's warm up with a quick activity to get our minds ready. And I call this game brain check. Okay, so this will help us recall what we already know or guess what the picture wants to tell us. And then this will also help prepare for today's discussion. Let's see how sharp you are. Okay, are you ready? All right. First, you have to identify the correct answer by guessing it to the picture presented. Now, it's your turn to take a pause of this video. Yes, you've got it right. It's raw score. Next, how about this one? Yes, you've got it right. It's percentage. How about this one? Yes, it's norm reference interpretation. Next, it's criterion reference. How about this one? Yes, it's T-score. So that was the end of our motivation part. I hope you are motivated. Okay. So now I have a questions. How did you find the activity? Is it hard or is it easy for you to guess the word? And what are the words that you guessed? Are you familiar with these words? Okay. So what do you think is the connection of these terms to our topic today? All right. Our topic for today is all about Utilization of assessment data. But before we proceed, let's have our learning objectives. First is we have to identify terms related to utilization of assessment data. Second one, provide meaning to test results using norm referenced and criterion referenced. And then indicate the importance of basic concepts and principles of the different types of test scores and interpretation. Now, have you ever wondered how teachers use test results to improve learning? As a student, we can easily identify our score after checking our test. However, we find it difficult for us to determine when we say what does our score means. So in this discussion, we will look at why using assessment data is important and how it can make education more effective. This discussion will explore the importance of assessment data, its practical applications, and how it supports evidence-based teaching and learning practices. First is we have test scores. Let's read it together. A test score is a piece of information, usually a number, that conveys the performance of an examinee on a test. Simply, it is the result a student gets after taking a test. It shows how much they know or can do based on the test content. And did you know that your test result can aid in making informed decisions to improve curriculum and instruction? Yes, you have heard it right. Now, let's break it by step explanation. Test score has its different types. So first is raw and percentage scores. Raw scores are obtained by counting the number of responses in a test following a scoring direction. So this is the total number of points a student earns. For example, if a test has 50 items and a student answers 30 correctly, then their raw score is 30. Now, how about the percentage score? Percentage score is useful in describing a student's performance based on a criterion. From the word percent, we usually use the symbol percent. A student who gets 20 of 50 items in English test correctly obviously gets a raw of 20. Now, how about the percentage score? How we formulate it or how will we calculate it? First, you have to divide the raw score by the total number of items, then multiply by 100. For example, from the previous example, 20 divided by 50 and then multiply by 100. So you can take a pause and then try to calculate it on your paper. 20 divided by 50 is equals to 0.4. That 0.4 will be multiplied by 100. So the answer is 40%. And that's the percentage score formula. So what would be the interpretation of that? So the student was able to answer 40% of the items. Now we have what we call percentile rank. Just remember, class, that there's a big difference between percentile rank and percentage score. In percentile ranks, we can determine the ranks of the student based on his or her score and compare the other rank to the students who took the test. A percentile rank gives the percent of scores that are at or below a raw standard score. It is used to rank students in a reference sample. So let's have an example. A score of 35 or a standard score of 1 falls in the 84th percentile, which means the student scored as well or better than 84% of students in the sample. We could also say that the student score is in the upper 16% of the norm group. If there were 200 students who took the test, a percentile rank of 84 indicates that the student scored higher than 168 students. Let us try to calculate it if this is true. Okay, so we have the percentile rank formula. Percentile rank equals the rank of the student divided by the total number of students multiplied by 100. But here, we try to seek or calculate the rank of the student. So we are already given the percentile rank, okay? And based on the provided example, so the percentile rank was 84. And then total number of students over 100. So you have only to modify the or substitute the formula because we are finding the rank of the student, so you have to substitute based on this percentile rank. First is percentile rank over 100. It means that 84 you have to 84 divided by 100, then multiply by n, which is 200. Alright, so how can we get the percentile rank? So we have a percentile rank formula. The formula is that rank of the student, the percentile rank equals rank of the student over total number of students multiplied by 100. But now, we have to substitute this formula. It's because we are seeking or finding the rank of the student. In substitution, it will become rank of the student equals percentile rank divided by 100 times n. You have to remember that the rank of the student is the number of students who scored below the given student plus 1 or positive 1. And the total number of students, it represents the capital N, right? So the total number of students is we have 200. And then the percentile rank, we have given an 84th percentile. So to solve for the rank of the students, just rearrange the formula. So it will become rank of the student equals percentile rank over 100 multiplied by n. Now you can take a pause and then try to calculate it with the given numbers. Percentile rank is we have 84 divided by 100 multiplied by 200. So what's the answer? Okay, so you've got it right. We have the answer 168, right? So you've got it right. So what does it mean? It means that the student is ranked 160th out of 200, which places them in the 84th percentile, scoring as well or better than 168 students in the upper 16% of the distribution. So are we all clear? Okay, let's proceed. We have the standard scores. Standard score is a derived score which utilizes the normal curve to show how a student's performance compares with the distribution of scores above and below the arithmetic mean. So standard scores compare a student's performance to a group. However, it will be very difficult if you will be comparing two two things or two situations. For example, a test on a math or a test result of a math student versus the test result of an English student. It will be very difficult for you to find out. It's because they have different level of difficulty. But we have a remedy on that. This is what we call a derived score. To solve the problem, raw scores may be converted to a derived score. So in relative standing, it compares a student's performance to others. For example, percentile ranks show the percentage of people a student scored higher than. If you are in the 90th percentile, you did better than 90% of students. Under this relative standing is what we have: percentiles, standard scores, and stanines. And in developmental score also, this measures growth or progress over time. For example, a reading level of grade 5.4 means the student is reading at the level of a fifth grader in the fourth month of the school year. So along the way, it will be very detailed along the way in this discussion, because it will be discussed by my co-discussants. And I know that they will explain this better. Okay, so next, let's proceed. Normal curve. Have you ever heard this term, normal curve, or have you seen this illustration below? Okay, so normal curve, it represents a normal distribution, a symmetric theoretical distribution. The mean, median, and mode are located at the center of the bell curve, where the peak is. The mean, median, and mode are located at the center of the bell curve. So as if we try to see here in the there is a kilid. There are words like z-scores, t-scores, stanines, okay, standard deviation, and then here in the illustration we have 0, right? And then we have also here the negative side and then the positive side. So in normal curve, uh, the mean, median, and mode are at the middle. It is expected that half of the test scores are below the mean and half are above it. So the mode indicates the most scores are at the average level. And then the curve approaches the horizontal axis asymptotically. And also the empirical rule shows the connection between the normal distribution and the standard deviation. It states that 68% of the total scores will fall within one standard deviation of the mean. For example, now 95% of the scores within two standard deviations, and almost all of the scores within three standard deviation mean. So now that we are already done with the slide of normal curve, I'll just want to sum it up. I just want to sum it up. So the normal curve or bell curve is used to show how test scores are distributed. Most scores fall in the middle, meaning the most students perform at an average level. Fewer students score very high or very low, and that was indicated the positive and the negative, right? If you can see. So for example, if the average score in a test is 75, most students will score around that range, while only a few will score much higher or lower. I hope you understood my discussion, especially the normal curve. Anyway, it will be discussed by my discussants. There they will uh, deep dive, or they will explain that um, comprehensively. Yes, especially the z-score, the stanine, and so on and so forth. I will give the floor to my co-discussant.
So, good day everyone. Now, we're gonna proceed to the Z score. So, we can read here that Z score gives the number of standard deviations of a test score above or below the mean. So, there is an old saying that you cannot compare apples and oranges, but with standardizing, it can be done to some extent. Suppose that a student, for example, suppose that a student scored 90 on an art test and 45 on an English test. Direct comparison of raw score is impossible since the exams might not be equivalent in terms of number of questions or value of each question and so on. However, a comparison of a relative standards similar to both can be made. So this comparison uses the mean and the standard deviation, and it is called a standard score of z-score. So as you can see here, we have a normal bell-shaped curve. So there is a line in the center. So this is what we call the mean. And this three line here, those are the each of the lines has it has its own equivalent. Now we have here a formula that where is z equals x, where z is the z score and x it is test score, and the x with the above line is the average score over S is the standard deviation. So please note that a negative z score means it is below the average, while a positive z value means it is above the average. So we have here another topic, t score. It is a family of curves based on degrees of freedom, which is a number related to a sample size. Now, when the population standard deviation is unknown, the z-test is not normally used for testing hypotheses involving mean. A different test called t-test is used. So, when the populate we are gonna calculate about the population of the standard deviation and it's still unknown, so we're gonna use t-test for this um for this test. Now the t-distribution is similar to the standard normal distribution in the following ways. We can see here a bell shape. It is bell shape. It is symmetric about the mean. The mean, median, and mode are equal to 0 and are located at the center of the distribution. We have here the 0 here in the center. And the curve is asymptotic. So when we say symptotic, it means approaching a given value or condition as a variable, or an expression containing a variable approaches a limit, usually infinity. So the differences about z test z score, z score and t score, is that the variance is greater than 1. And the t distribution is a family of curves based on the degrees of freedom, which is a number related to sample size. As sample size increases, the t distribution approaches the normal distribution. So, what is the t score formula? So, a t score is one form of standardized test statistic. And the t score formula enables you to take an individual score and transform it into a standardized form, one which helps you to compare scores. So we have here, you want to use this t-square formula when you don't know the population standard deviation and you have a small sample which is under below 30. Now this t-square formula is given here below in the figure where the underlying x above is the sample mean and we have the downside u which is the population mean, and s is the sample standard deviation, and n is the sample size. if you only have if you have only one item in your sample, the square root in the denominator becomes 1, square root of 1. This means the formula becomes t. So we're gonna use another formula for this. So what I've said earlier, that the larger the t score, the larger the difference is between the groups you are testing. So it influenced by many factors, including how many items are in your sample, the means of your sample, and the mean of the population from which your sample is drawn. So we have here another formula under the T. We have the degrees of freedom. So you traditionally to look up a T score in a T table. So the number of items in your sample minus 1 is your degrees of freedom. So it's very simple. For example, if you have 20 items in your sample, then you simply minus it with 1. So your degrees of freedom is 19. So you use the degrees of freedom along with the confidence level you are willing to accept to decide whether to support or reject the null hypothesis. So we have here STAN9. So STAN9 is a method of scaling scores on a 9-point scale. Raw score is converted to a whole number from a low 1 to 9. So the meaning of this is that any test score can be converted from its original scale from, for example, 1 to 50 to a score between 1 to 9 in order to compare a group of scores. Stan 9 is an abbreviation for standard 9. Since the Stan 9 scale consists of 9 units ranging from 1 to 9. So obviously, I've given you this illustration here for you to have a reference. And this is already an example. So stand 9, the column stand 9, we have here 9 going to below 1. And we have PR, which is the example of numbers, raw score to um, to 1 to 99. So we have here a formula. Stan 9 equals 2, where Z is the Z score, plus 5. So Stan 9s have a mean of 5 and a standard deviation of 2. And you have to take note that 1, 2, and 3 are below the average, and 4, 5, and 6 is the average, and 8, um, 4, 5, 6, 7, 8, and 9 is the highest average. So we have here normal curve equivalent. So it is normalized standard score within the range 1 to 99. It has a mean of 50 and a standard deviation of 21.06. So caution should be exercised when converting a raw score to NCE or normal curve equivalent because the latter requires a representative national sample. Score differences between tests and among subtests in a test battery can be calculated and examined. For example, an NCE of 30 in reading is twice as far from the mean compared to an NCE of 40 in mathematics. The student's score in mathematics was 10 points higher than in reading, but both are still below the average score of 50. So that's all for my part, and I hope you'll listen to my other co-discussant. Thank you.
Now let's proceed to the last subtypes of standard score, which is the developmental score. So, developmental score is a grade equivalent that describes the learner's developmental growth. So, it gives a picture as to where he or she is on an achievement continuum. So, grade equivalent is an estimate of a learner's location in the developmental continuum and not the grade level where he or she should be placed. Like, for example, if the child kono of if the child scores in a reading comprehension is equal to an age equivalent of 7.6 years, it means that the child's raw score is equal to the average score of children 7 years and 6 months in the norm group who took the test. So this it does not imply kuno that the child necessarily performed at the age level of 7.5 years. So using measuring the developmental scores of the students or of the learners, it helps to assess the child's progress in areas like physical, cognitive, emotional, social, and language development based on age appropriate milestones. So developmental scores not just more on academic subject, but it talks about or it more about child's overall growth and readiness in various domains. So developmental score, it is developmental score, it is a measurement used to assess a person's or child's progress in a various areas of development. So by using the developmental score, it can help identify the areas where a child or your learners may need additional support or intervention to reach age appropriate developmental standards. So that's what developmental score talks about. So now let's proceed to the types of test score interpretation. So there are two types of test score interpretation: the norm reference interpretation and the criterion reference interpretation. So this two is to used to evaluate and interpret assessment result. So now let's first tackle about norm reference interpretation. So the term norm kono is originated from the Latin word norma, so which means precept or rule. So by its definition, it pertains to the average score of the test apart from the school average norm. So apart from the school average norm, so there are other types of norms that can be reported. It could be international, national, and local impaired. So norm reference interpretations are explanations of learners' performance in comparison with other learners of the same age or grade. So it is a learner's knowledge in terms of his or her position in the norm group. So the use of standard scores and percentile rank kono are common in the norm reference interpretations. Like for example, to say kono that the child placed 8th in a reading class is a norm reference description. So another example, a child's score in reading assessment at the 85th percentile. So this means the child scored better than 85% of the students in the group. So norm reference, it is um, a type of a type of interpreting results, or it is used to assess or interpret the assessment results. So it measures the student's performance in relation to the performance of a group on the same test. So, Nitko and Bukhart 2011, so they stated 5 guidelines when interpreting norm references score. So, the first one is detect any unexpected pattern of score. So, if a student's test score does not seem to corroborate teacher's observation of student's performance, then the teacher should reflect on his or her instruction. So the second one is to determine the reasons of score pattern. So there is a reason why a learner is underperforming in one or more subject. So the possible reason should be maybe the students or the learners have learning disabilities or have a problem on motivation. So the third one is do not expect surprises for every student. So the teacher must know how each student is performing in his or her class. So the fourth guideline is the small differences in subject scores should be viewed as chance fluctuation. So it means that the differences in test scores may or may not be statistically significant to call for instructional intervention. So the last guideline of the norm reference test score is use information from various assessments and observations to explain performance on other assessments. So it means that it would not be shocking to learn that students with poor writing skills in English and Filipino would obtain a low score in the essay portion of a test. So now, let's dive into criterion reference interpretation. So, when we talk about criterion reference interpretation, it describes each student's performance against an agreed upon or pre-established criterion or level of performance. So, the word criterion came from the Greek word criterion, which means standard. So, criterion reference interpretations provide meaning to test scores by describing what the learner can and cannot do in light of a standard. So, hence, test scores allow for absolute interpretations and not comparative. So, a learner's performance is explained in relation to a predetermined criterion of mastery. So mastery test generates criterion reference interpretation. So do the teacher made tests, skills tests, competencies tests, performance assessment, and licensure examination. So it could be they used in doing an assessment. They could they should probably use some multiple choice questions, alternate response items, short response, and essays enable criterion reference interpretations, since these task formats can be used to measure specific body of knowledge or skills sets that students have acquired. So, however, the breadth and content is narrow. So now let's talk about the differences between the norm reference and criterion reference interpretation. So, what is the aim or purpose of a norm reference assessment or interpretation? So, Well, the goal of this kanang reference or reference interpretation is to rank based on a test achievement scores. So in a norm reference assessment, scores are given has a rank and they are based on other students' scores. So similar to a race where competitors are ranked for gold, silver, and bronze. So in terms of norm reference test, it would differ from criterion references in number of students tested. So the norm reference test usually assess a large number of students and it take a longer time to develop, and this test take a longer period of time for the students to complete as well. So norm reference assessment develop on a state or national level. So on the other hand, the criterion reference interpretation. So the goal of this assessment is to measure the skills and knowledge that a student has mastered. So the mastery of criteria. So for criterion reference assessment, the student scores are usually give as a percentage. So if a student gets all question right, for example, that is 100%. So criterion reference test usually assesses a small number of students. So these tests are not the same, are not long as norm reference test. So this test usually last only about a class period. So criterion references can be developed individually, so they are mostly created by the classroom teacher. So, in a criterion references, the performance of the other students does not affect the students' scores.